Hello, men and women of science. This is Mr. Cochrane to talk about dimensional analysis and conversion factors. This is also called the factor label method because we treat labels like they're variables in an equation that will factor out. So here we go. Conversion factors are ratios containing equal values of different units. Because they're equal values and you put them in a fraction, they're also equal to 1. So when we multiply by a conversion factor, we're just changing units, not the true value. So there's some conversions that you already know. There's 24 hours in a day. There's a kilogram to 2.2 pounds, and maybe you knew that, maybe you didn't. There's a meter is equal to 39.4 inches. And so these are some conversion factors, some ratios of those equal values that we could use to convert from one unit to another. The conversion factor you choose would depend on what you're trying to accomplish. Here's a couple more. 55 miles per hour. Whenever you have a per, like miles per hour or grams per milliliter, that means per one of the other things. So 55 miles per hour means an hour for every 55 miles, or 55 miles for every 1 hour. 7.9 grams per milliliter. What would the two conversion factors for that be? Yes, it would be a milliliter per 7.9 grams, or 7.9 grams per 1 milliliter. And we could use density then. This is, maybe you recognize this as density. We could use density as a conversion factor to go from grams to milliliters or from milliliters to grams. Here we go. We're going to treat the labels, like I said, as variables that can factor out. What you want to do is write down the starting value you're given, the value you're converting from, and make sure you write down the units with it. It's hard to factor out units if you don't have them written down. Then you're going to choose a conversion factor. Excuse me, let's go back to that. You're going to choose a conversion factor that factors out the units you have and gives you the units that you want. So here we go. Let's try one. How many hours are in 32 minutes? Conversion factor for minutes to hours would be 60 minutes per 1 hour. So we write down the given amount, 32 minutes. We're going to choose the conversion factor, an hour per 60 minutes. The reason we're putting minutes on the bottom is it allows the minutes to cancel out, and we get our answer in 0.53 hours. When you're doing these conversion problems, you divide by any of the numbers that are on bottom and multiply by any numbers that are on top. And the units you're left with should be the units that you're looking for. In this case, it was hours. There's a simple example. Let's look at another one. How tall are you in meters? So in order to answer this, you would need to know how many inches are in a meter and how many inches tall you are. So as we said earlier, there's 39.4 inches per meter, and we're going to start with our height in inches and show all our work here. I happen to be about 67 inches tall. And so when I multiply by a conversion factor, I'm going to want inches on bottom and meters on top. That allows me to factor out the inches. Inches divided by inches factors out. And I am left with meters. So 67 divided by 39.4 is 1.7. And we're going to round to 2 sig figs because 67 inches has 2 significant figures. For the most part, we're not going to allow our conversion factors, unless there's something that we actually measured, to affect our overall sig figs in our answer, but our starting value almost always will. You're wrestling 105 kilogram sumo. How much does he weigh in pounds? And we know from earlier that a kilogram equals 2.2 pounds. So again, you start by writing down the given amount, 105 kilograms. We want a conversion factor that factors out kilograms and gives us pounds. In that case, it's 2.2 pounds on top over kilograms. That way, kilograms factor out. So we have 105 times 2.2, and that equals 231 pounds. And again, the 2.2 doesn't limit us to 2 sig figs. The 105 kilograms limits us to 3 sig figs there. So we express our answer to 3 significant figures. We'll be working a lot in science with metric prefixes, and so these are some of the prefixes that we would like you to know. The ones in green are nice to know, but they're not required that you know them. And we're going to then look at what are some equivalent values for these. If you want to pause and write these down, you can, but this next slide might be a little bit easier for you to memorize. These are some equivalent values. And notice that these metric prefixes, centi, milli, micro, and kilo, all have the same meaning. Doesn't matter what they're in front of, whether it's meters, grams, liters, or seconds. So the prefix centi means 1/100th, and so it takes 100 centimeters to equal 1 meter, 100 centimeters to equal 1 meter. It takes 1,000 millimeters to equal 1 meter, so 1 millimeter is 1,000th of a meter. A micrometer is 1/millionth of a meter, and a kilometer, a kilometer, is 1,000 meters. The kilometer, or the kilo prefix, is the only one that is equal to more than one that we're asking you to memorize. So again, 100 centis to one thing, 1,000 millis to one thing, 1,000,000 micros to one thing, and 1,000 things to equal 1 kilo thing, whatever those things would be. So we're going to try a little more complex metric conversion here. We're going to convert from 0.0250 milligrams to micrograms. Because we have two metric prefixes in this problem, we're going to do two conversions. We're going to convert to what's called our base unit, in this case grams, so from milligrams to grams first, then grams to micrograms next. Here we go. We're going to leave space for two conversions, but we're going to start first, again, by writing down our given value, 0.0250 milligrams. The conversion for milligrams to grams is 1,000 milligrams to equal 1 gram. That allows us to factor out milligrams. Then we're going to multiply by 1,000,000 micrograms per gram, and that allows us to factor out grams and gives us micrograms. And the answer then would be 25.0 micrograms. So 0.0250 divided by 1,000 times 1,000,000 would equal 25.0. And our units that we're left with is micrograms. Here, we need this 0.0 at the end because if you notice, this has three significant figures in it. We have a decimal present, 1, 2, 3 sig figs counting from the Pacific side, from the first non-zero, so our answer needs to also have three significant figures. So if we'd just written 25, that would have not been expressed to the correct number of significant figures. So I hope you found this tutorial on conversion factors and dimensional analysis helpful. If you have any questions about it, ask your teacher for help. This is Mr. Cochrane signing off.